Using the Sine and Cosine Rule with Tutor. Here are the beginner questions, some of the easiest questions that you're likely to find on this topic. The Sine and Cosine rules can be used as methods to find missing angles or lengths, typically in non-right angled triangles. We need to identify which rule to use based on the information given to us in the question. This is usually the part that people struggle with. You can use the sine rule when you have two pairs of opposite angles and lengths, as shown, where one of the lengths or the angle is an unknown, which we're trying to find. The sine rule is a over sine A equals b over sine B, where lowercase a would be the length that we're trying to find, in this case f, and the capital letter A being the opposite angle of 59 degrees, and the relationship between this length and angle is equal to the relationship between the green pair of 25 over sine of the opposite angle 48 degrees. To solve and find f, we can make f the subject. This would involve multiplying both sides by sine 59. Therefore, f would be equal to 25 multiplied by sine 59 over sine of 48. This gives me a length of 28.8 meters when rounded to three significant figures. For the next question, we need to find the size of the missing angle K. Notice how the non-right angled triangle, we have a pair of opposite angles and lengths, followed by a second pair of opposite angles and lengths, where one of the angles is unknown, and that means that we can use the sine rule to find the unknown angle. A over sine A equals b over sine B is the version of the sine rule that's most remembered, but this can be correctly rearranged to sine A over A is equal to sine B over B, and this is more desirable when finding the angle, because in this case sine of the angle K is now at the top of the fraction, which will make it easier to change the subject and solve to find K. The opposite length can be used for the lowercase letter of 14.4 underneath, and the second pair of opposite angles and lengths would be sine of 95 over the opposite length of 20.5. Just like before, I can multiply both sides by 14.4 to begin to make sine k the subject, meaning sine k will be equal to sine 95 multiplied by 14.4. We need to be careful when typing this on our calculator, as when we push sine this will open a bracket, and we want to make sure that we do sine of 95, close the bracket, and then multiply the result of this by 14.4. If we don't close the bracket, our calculator will think that we're doing sine of 95 multiplied by 14.4 inside the bracket and will give us the wrong result. Alternatively, you can just put 14.4 at the beginning and your calculator will successfully compute this without having to close the bracket for sine 95. This is being divided by 20.5. This will give us the result for sine k, whereas we just want the value of k. To get from sine k to k, we need to use the inverse function of sine, which would be k equals inverse sine, or sine to the negative 1, of 14.4 times sine of 95 over 20.5. This function can be found by pressing Shift on your calculator and then the sine button, which gives us sine to the negative 1. So k would be equal to 44.4 degrees to one decimal place. For the next question, we need to find the missing side, labelled as f. Notice how this question does not contain two pairs of opposite lengths and angles. Instead, we have one pair of opposite length and angle with the other two lengths provided. This will allow us to use the cosine rule, which can be used when you're trying to find an unknown angle or length that are opposite each other with the other two lengths provided. The most commonly used version of the formula for the cosine rule is a squared equals b squared plus c squared minus 2bc cos of a, where lowercase a and uppercase A are the pair of opposite angle and length, and lowercase b and c are the other two lengths highlighted green. Lowercase a would be the length we're finding, labelled as f, and uppercase A is the opposite angle of 19. B and C will be 7.8 and 11.2. It doesn't matter which way round you label B and C for the other two lengths. Typing this on my calculator will give me a value for f squared of 21.07899, and square rooting this will give me my value for f, which is 4.59 rounded to three significant figures. For the last question, we're finding the size of the missing angle, labelled as Q. Notice how this is an unknown, but we have the opposite length. So we have one pair of opposite angle and length, where the other two lengths are known, meaning we'll be able to use the cosine rule to help us find this missing angle. The formula for the cosine rule can be rearranged to give us cos A equals, meaning we have the part that involves the angle as the subject, a squared minus b squared minus c squared over negative 2bc. This is worth remembering for your exam, rather than having to rearrange the formula whilst in the exam. This can also be written in a slightly different format, which is more commonly used, where we have b squared plus c squared minus a squared over positive 2bc. Either of these can be used and will provide us with the right answer. Using the second more commonly used version of the formula, uppercase A is the angle to be found, labelled as Q, lowercase a is the opposite length, and B and C are the other known lengths of 11 and 3. Again, it doesn't matter which of them you label as B or C. As we did previously with the question that involved sine of K, we can use the inverse sine function to work out K. So in this case, we can use the inverse cos function to work out Q. Q would be equal to shift cos, which gives us the inverse function cos to the negative 1 of the calculation, gives me a value for Q of 63.0 degrees to 1 decimal place. On to the intermediate question with an increase in difficulty and something more similar that you're likely to see in your exam for the higher paper. We need to work out the length of BC. When you have a compound shape made up of more than one shape like this with the two triangles, it's unlikely we'll be able to use the triangle on the right with enough information to be able to find the answer of BC straight away, which I'm going to label as Y. Instead, it's more likely that we'll be able to start with the other triangle on the left hand side and work out some additional information that will help us with the triangle on the right hand side. This usually involves finding the shared length between the two shapes. I'm going to label the shared length BD as X. With a focus on the triangle highlighted blue, notice I have one pair of opposite angle and length, followed by a second pair of opposite angle and length, where one of them is unknown to be found. This will allow me to use the sine rule. Since I'm finding the length, I'll use the version for the formula of the sine rule, where lowercase a is written as the numerator. So a over sine A will be equal to b over sine B, where lowercase a is the length to be found of X, and uppercase A is the opposite angle. Lowercase b is the other length of 7.4, with uppercase B being the opposite angle of 80. Multiplying both sides by sine 45 will allow me to find X, which will be 7.4 multiplied by sine 45 over sine of 80. This gives me a value for X of 5.313. Since the question wants us to find a length to 3 significant figures, it's important you use at least 4 significant figures with any of the numbers that you're rounding along the way. This will avoid any rounding errors by the time you get to the end. So I've worked out the length X, which is BD, and is 5.313. Now I can shift my attention towards the triangle on the right hand side. There is some other information which is quite straightforward to find. Knowing that this angle is 80 degrees and it forms a straight line with the angle BDC, I can quite quickly find this angle by doing angles on a straight line add up to 180. So 180 minus 80 will give me an angle of 100 degrees. Now I have a triangle which involves one opposite pair of angle and length, where one of them is unknown to be found and the other two lengths are provided. The one I've worked out, which is 5.313 and 5.8. This will allow me to use the cosine rule. And again, since I'm finding the length labelled as y, the version of the formula that will be most helpful is a squared equals b squared plus c squared minus 2bc cos a, where lowercase a is the length to be found, labelled as y. Uppercase A is the opposite angle of 100, and B and C are the lengths 5.8 and 5.313. Using my calculator, this gives me a value for y squared of 72.57, and square rooting gives me 8.5188, which to 3 significant figures would round to 8.52 centimeters. The length BC is 8.52. On to the advanced question, with one of the trickier questions that you're likely to find on this topic. We need to find the bearing of Chorlton from Acton. It helps if you connect the points that you're finding the bearings between with a straight line. We're going from Acton, which is this point. When measuring bearings, we always measure from north, and we go clockwise until we get towards the direction that we're heading towards, which is this line towards Chorlton. This angle is already labelled as 37 degrees, so really the question involves finding this angle inside the triangle, which I'll label as theta, to give us the total angle when we add it to 37 at the end. Firstly, try and find as much information on the diagram as you can in order for us to use the sine and cosine rules. When completing questions involving bearings, because bearings need to be measured from north, the questions often involve parallel lines, and we can use our knowledge of angles between parallel lines, such as corresponding, alternate or co-interior angles, to find some of the missing angles. If the angle labelled by A is 37 degrees, this forms a co-interior angle with this one at B. Co-interior angles add up to 180 degrees, so 180 minus the known angle of 37 gives me an angle of 147 degrees. If this angle is 147, I can use my knowledge of angles around a point being equal to 360 degrees to find this unknown angle. 360 minus 143 minus 150 is equal to 67 degrees. I'm now getting closer towards being able to work out theta. Theta has an opposite length which is known. I've just found an angle of 67 degrees. If I can find the length of AC, I should be able to use the sine rule with my two opposite pairs of angles and lengths and one unknown. I can find this length since I know the opposite angle and the other two lengths are known, which will allow me to use the cosine rule. Using the version of the formula where the length forms the subject, a squared equals b squared plus c squared minus 2bc cos a, where lowercase a is the length to be found, which I'll label as x. X squared equals one of the known lengths squared, 8 squared, plus the other known length squared, 9 squared, minus 2 lots of 8 multiplied by 9 times cos of the opposite angle of 67 degrees. My calculator will give me a value for x squared of 88.7347. Square rooting this will give me a value for x of 9.4199. Now I know the length AC, I can go ahead and use the sine rule to find the missing angle theta. I want to use the version of the formula where the angle forms part of the numerator, where we have sine A over A is equal to sine B over B. Uppercase A is the angle to be found, labelled as theta, and lowercase a is the opposite length, 9. This is equal to sine of the second angle over the opposite length, which I've just worked out to be 9.4199. Theta would be equal to multiplying both sides by 9 and doing the inverse function of sine would give me sine to the negative 1 of 9 multiplied by sine 67 over 9.4199. Theta is 61.578, which will need to be added to the original angle next to it of 37 to give me the total bearing of 98.6 degrees to 1 decimal place. Bearings have to be written as 3 figures in front of the decimal point. So if we finish with an answer with 2 figures, such as 98, we have to put a 0 in front as a placeholder, so we end up with 3 figures. This is a really common way to lose a mark at the end of a question, so something to look out for. Here's a question that I've completed earlier. I've made some mistakes. Pause the video and see if you can spot what they are and write some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.